What if the waste we throw away could create something valuable? Every year, the world produces 2 billion tons of solid waste. In Indonesia, 3.2 million tons of plastic waste go unmanaged annually, polluting rivers and landfills. In Yogyakarta, waste is often burned and dumped. Yet, as a city known for its crafts, it holds untapped potential for turning trash into treasure. That's why we created WasteWise. Using machine learning, our app identifies waste from photos and provides craft recommendation. Together, we can educate the community, reduce waste, and support sustainability.
I want to show you some comparison that we have made. So right here, we compare our WasteWise application with two other application that is also talking about waste. We are comparing it with Trash Out and also Recycle Coach. You can see right here, it also have different result for the comparison points in which WasteWise comparison point can only be checked on the attractive UI UX, trash identification using image recognition, and craft from trash recommendation. As you can see right here also for the other application, it also have different checkpoint. Next, I'll be talking about the implementation and the advantage of our application. Our application tried to connect between the waste problem and craftsman. That's why this application focuses more on providing ideas for products made from waste processing. And that's why the advantage for this application is first, smart waste classification, in which when you upload the image, you'll get the result. Next, it will also give you some creative upcycling ideas. So you will know like what you can do with this waste. And also, we try to implement user-friendly interface and focus on environmental awareness and creativity. Next, I'll be talking about the demo for these apps. Here, you can find the welcoming page, and when you click Start Here button, you'll be directed into the login page. And you can fill your email address and password that you have made before and have been registered in our database. After you log into this account, you'll be directed into the home page where if you click the scan icon right here, it will direct you into the upload page. And right here, you can upload the waste image by using camera or gallery. And then when you click analyze, you can see the result, this kind of image. If you click one of this recycle recommendation, it will direct you into detailed recommendation where you can read more about how you can recycle those waste.
Now, I'll continue by explaining the tools we use in this project. For cloud computing, we use Google Cloud, Node.js, Python Flash, and Docker for development and container management. In machine learning, we use Python, TensorFlow, the Python Notebook, and Google Colab. For mobile development, we use Kotlin, Android Studio, Glide, Docker, and Figma. Next, I walk through the Google Cloud architecture for the project. We utilize Google Cloud Platform in the Asia Southeast region. The project code is stored in GitHub, and the WasteWise database is managed with Code Asia. The development pipeline is automated with code build, and containers are processed from artifact registry. The machine learning API runs on Cloud Run, and the main WasteWise API is hosted on App Engine. Models and images are stored in cloud storage, ensuring accessibility to mobile devices. With this architecture, we ensure efficiency, scalability, and smooth collaboration.
Now, I will explain how we implemented image classification in this project. First, we prepared a trash image dataset and labeled each image according to its category. Next, we built a model using transfer learning with MobileNet V2, train it on the dataset, and test the model to predict the type of trash from given images. Here, the prediction results are displayed. And finally, we save the model for further use. The results of the model development are represented through the model summary and a chart of training and validation accuracy. The model achieved an accuracy of 90%, which is sufficient to support the application's goals. For testing, we use Streamlit as the interface, allowing us to predict image directly. Additionally, we analyzed the prediction result using a confusion matrix to evaluate the model's accuracy for each category.
This is an overview of the clean architecture used in our mobile application. This architecture divides the application into three main layers: presentation, domain, and data. Starting from the presentation layer, where the user interface or UI becomes the main interaction place with the application, supported by the presenter that connect the UI with the logic in the domain layer. Moving on the domain layer, there are use cases that run the main business logic, as well as entities that represent the core data used through the application. And finally, at the data layer, there are repositories that serve as the hub for retrieving and sending data via web API service. With this structure, the application is designed to be more organized, easy to test, and flexible to deal with future change. Next is MD deployment process. This application starts with the prototype stage, where the idea of the application is realized in the form of an initial design. Then it goes to the lighting stage, where the visual structure of the app is built. Stage is getting app with dummy data, which is the creation of application using temporary data to test its appearance and logic. After that, API implementation. This is to integrate the application with the backend. And finally, the testing stage ensures all the features are running properly before the application is released.
Okay, and this is a documentation about our project. And as you can see, there is a GitHub link in here. And now, this is a mobile development pad. If you want to try this setup by yourself, first you want to ensure you have to Android Studio installed on your machine and device or emulator with Android 6 or higher. And then clone this repository to your local machine with this syntax. And then open your project under Studio and then change project dependencies by Gradle. If there is no error, you can run the application on the Android device or emulator. And then cloud computing path. The first one is you need to make your folder and then install the dependency with npm install and then create MySQL database and then you need to make the environment file and then set the database URL with your own MySQL address and then apply the quick Prisma migration. If you not meet any errors, you can run npm run dev to run it. And then machine learning path. To install it to your own, you need to have Python on your machine and then TensorFlow library and then Jupyter Notebook library. And the step one is you clone the repository by the address and then you need to insert the repository and then set up the environment to install the library. And then you open the Jupyter Notebook file, launch Jupyter Notebook and then execute your cell step by step to the training model. And this is a planned local deployment for our project. And this is the timeline actually for the next 6 months, for January to June. For the first month in January, we're going to focus on NLP feature and YOLO integration. And then in the February, we focus on deploy it to the Play Store and branding the digital market. And then connect to the craftsman community in the March. Then review and evaluation about this product in March too. And the last 3 months, we're going to focus on craft online shop feature.
In the next slide, I'll be going over the budget plan that covers over the project expense in the next 6 months. So, as you can see here, there's team sellers that consists over machine learning, mobile developer, cloud computing, and also digital marketing. The budget also covers over digital tools that will help us in developing and deploying our app. So in total, it costs over 114 million rupees. There are also strategies that will help us in building long-lasting relationships with users and also maintaining consistent revenue streams. Our freemium model subscriptions, in-app advertising, generating profits, and also plenty of meaningful user interaction such as the share and discovery features would help us in remaining profitable while also delivering value. That is all from our presentation today. I hope you may find this presentation to your liking, and I would like to say thank you.